So now, remember from Algebra 2, when you're multiplying two fractions together, what you want to do when you're dealing with rational functions, you see that you've got variables in the numerators and or denominators. You want to factor the numerators and denominators wherever possible. So notice on the numerator of my first fraction, there's a greatest common factor I can pull out. So I'm going to pull out an x and I'll leave me with an x minus 2. Over, notice I've got a trinomial, factors of 1 that add together give me 2, x plus 1 times x plus 1. Times, you can factor this numerator, that's going to give me an x plus 3 times x plus 1. Notice in the denominator there's a GCF of x I can pull out, and that gives me an x plus 3. Now remember, when you're multiplying fractions, you just multiply straight across. You do not need to have a common denominator. What you want to try and do is you can cross cancel common factors, so look for what's same on the top as is on the bottom, and you can cross those out. Notice I have an x plus 3 on the top here and an x plus 3, so I can cancel out that common factor. I have an x down here and an x over here. I can cross that one out. I can cross cancel an x plus 1 as well. Now whatever's left, I'm just going to multiply straight across. Notice the only thing left in the numerator is an x minus 2. Over, I have an x plus 1 left on the bottom. Remember, fractions are grouping symbols. There's actually parentheses around the top and the bottom. You cannot cross out these x's. This is one whole expression, or I call this one animal. If you try and cross out the x's, you've just chopped your head off your animal. We're not going to decapitate our animals. So this is our final answer. Remember, in number 6, this actually is a fraction over 1. So my numerator is x squared plus 10x minus 24. So I can factor that into x plus 12 times x minus 2, all over 1. Remember, when you're dividing fractions, you actually multiply by the reciprocal. So when I factor 3x minus 36, I can take out a 3, and that'll leave me with an x minus 12. X squared minus 44 is a difference of squares. That will factor into x plus 12 times x minus 12. So when I divide, I'm actually going to multiply by the reciprocal. So the numerator here is going to be 3 times x minus 12 over x plus 12 times x minus 12. So now, just like I did in problem number 5, I'm going to look to cancel common factors from the numerator and denominator. Notice I have an x minus 12 in the numerator, x minus 12 in the denominator. I can cross cancel. X plus 12 down here in this denominator, x plus 12 in this numerator. The only thing that's left in the numerator is an x minus 2 times 3. So 3 times x minus 2 would be my final answer, over 1. And you don't need to write the 1. So like I mentioned a few minutes ago, remember, when you're dividing fractions, you're simply going to multiply by the reciprocal. So I can factor this numerator. I can factor out a 7x. That'll leave me with an x minus 3. Over. I can factor this. Factors of negative 35 that add together give me negative 2, or x minus 7 times x plus 5, times my x minus 7 over x squared. So the common factor I can cross cancel is an x minus 7. Notice I have an x squared in the denominator and an x on the top, so I can cross out my x up here with one of my x's down in the denominator, which is going to leave me with a single x in the denominator. So I multiply straight across. That's going to give me 7 times x minus 3 over x times x plus 5. So just like I've been doing, you may have trig functions that you have to deal with multiplying. So there's no factoring to be done in either of these fractions. So what I'm simply going to do is just multiply straight across. So I'll have 15 sine to the third theta cosine squared theta over 10 sine squared theta cosine theta. Again, you could have written a cosine times sine. I just wanted to keep my like terms lined up. Now what you're going to do is you're going to simplify each common base. So 15 over 10 are my constants. So look at that fraction. If I was to simplify 15 over 10, I can divide a 5 out. So that's going to give me a 3 over 2. I have 3 sines on the top 2 signs on the bottom. Notice I could cancel out 2 signs, but that's going to leave me with 1 on the top. So I'm going to have a sine theta in the numerator. I have 2 cosines on the top, 1 cosine on the bottom. I can cross out 1 cosine, and that's going to leave me with a cosine theta in the numerator. So all the same rules we use for x's we can use if they're trig functions. So let's take a look at number 9. So for number 9, remember this tangent theta plus 2 is a fraction over 1. So I'm multiplying, so I don't need to flip the fraction that comes after the multiplication sign. Tangent squared minus 25 is a difference of squares. So I can factor in a tangent theta minus 5, tangent theta plus 5, over tangent squared minus 3 tangent theta minus 10. If it makes you feel more comfortable, remember we talked about this, you can always replace a tangent with an x. Deal with this as an x squared minus 25 over x squared minus 3x minus 10. Factor it in terms of x, and then you can bring the tangent back in. So if I factor x squared minus 3x minus 10, that factors into x minus 5 times x plus 2. Now replace x with the tangent. So tangent theta minus 5, tangent theta plus 2. Notice I can cross cancel that tangent theta plus 2, cross cancel or cancel out the tangent theta minus 5. So now when I multiply straight across, I'm just left with a tangent theta plus 5 in the numerator over 1, or just a tangent theta plus 5. So now notice you have another division problem. So I have to flip the fraction that comes after my division sign. So this is going to become sine squared theta plus 7 sine theta all over sine squared theta minus sine theta minus 6. Remember, if you want to deal with this in terms of x, you can replace the signs with an x. So I could factor sine squared plus 3 sine plus 2, that's going to factor into sine theta plus 2 times sine theta plus 1. Or like I said, you could look at this as x squared plus 3x plus 2, factor it, and then replace your x with the sign. Over. The only thing that's in common in the denominator is I can factor out a sine theta. That's going to leave me with a sine theta plus 1. Don't forget when you factor out GCFs, you have to divide. So sine theta divided by sine theta is a 1. Times. So I can factor a sine out of the sine squared theta plus 7. So that's going to give me a sine theta plus 7. Over. Factors of negative 6 that add together give me negative 1 will be a minus 3 and a plus 2. So now let's see what I have in common that I can cross cancel. I have a sine theta plus 2. I have a sine theta plus 1. I have a sine theta here and a sine theta here. Nothing else in common, so when I look at my numerator, the only thing I'm left with is that sine theta plus 7 over, only thing left on the bottom is a sine theta minus 3. No, you cannot cross out those signs. So when you look at number 11, remember number 11 is a fraction over 1. Again, I have to multiply by the reciprocal, so I have to flip this fraction. Remember, if you're more comfortable, replace the cosine with an x. So when I look at cosine squared theta plus 2 cosine theta minus 8, if you want to, look at it as x squared plus 2x minus 8. Factors of negative 8 that add together give me 2. It's going to be a cosine theta plus 4 times cosine theta minus 2 all over 1 times. I can factor a 2 out. I have another difference of squares in the denominator, so that's going to give me a cosine theta minus 4 times cosine theta plus 4. Now I've multiplied, so I can cross out the cosine theta minus 4s, cross cancel the cosine theta plus 4s. The only thing I'm left with in the numerator is a cosine theta times 2 or 2 times cosine theta minus 2. So that's how you can multiply and divide rational expressions, including the with irrational expressions with trig functions.